Basically, there are two types of machines. One is general purpose and second one is a special purpose machines. The sewing and pressing equipments may be either general or special purpose. General purpose machines are basically operated manually and can perform a variety of operations. Special purpose machines are designed to perform a specific operation and more likely to be or semi-automatic or automatic. Sewing machine fundamentals. A basic sewing machine or sewing head, as it is sometimes called, consists of the fundamental parts required to form a stitch, sew a seam, or perform a specific sewing operation. The major components of a basic sewing machine include a casting, a lubrication system, a stitch forming system, and a feed system. The speed at which a machine can operate depends on the engineering of the machine's components. The casting. The machine casting is the metal form that provides the exterior shape of the machine. Shapes vary with the bed type. The sewing function that is to be performed and how piece goods are to be presented to the needle. The casting houses the internal workings such as the gears, cams, and shafts that operate the stitching and feeding mechanisms. Bed types. The bed is the lower portion of the machine under which the feed mechanism and loopers are located. Sewing machines are frequently described by bed types. Mainly it is flat bed, cylinder bed, feed of the arm, post bed, and raise bed. These 5 different types of the machine beds are being used in sewing machine. The table illustrate the various types of machine bed along with their usage. The first type of sewing machine bed is flat bed machine. This is the most basic or common type of sewing machine. The stitch type in flat bed is lock stitch or chain stitch. Features and uses. The large working area allows a wide range of application. The material can easily be guided around the needle and the pressure foot. This basic type is used for all kinds of flat sewing machine. Next bed type is raised bed machine. Raised bed machine also used to be in stitch type of lock stitch and chain stitch. The features and uses of raised bed machine is bed plate is in the form of a plinth. It facilitates the assembly of pre-sewn parts and is especially suitable for the fitting of accessories and special attachments. This is the basic form for various specialized machines such as button holders. Post bed machine. The stitch type is lock stitch and chain stitch. This type has an increased working height. Special applications are found in the working of three-dimensional products, that is shoes and bags. The post makes it easier to work on tight curves and corners, to sew in sleeves and to complete large half assembled products. Cylinder bed machines or lock stitch and chain stitch machine types, stitch types used to be there. This type has an increased working height and a bed in the shape of a horizontal arm. It is especially suitable for shooting tubular parts such as cups, sleeves, and trouser legs, and it is used for button sewing and bar tacking also. It is used extensively in the making of clothing from knitted fabrics. Side bed machines, chain stitch and overedge. The stitch types are. The feature of this particular machine is machines which are specialized for sewing at edges need only a small working area. The Lockstitch machine. The modern mass production sewing requirements have resulted in many variations of the basic flat bed Lockstitch sewing machine. As we have seen, many of these developments are concerned with the form of the bed on which the material to be sewn rests. Cylinder beds, post beds, raised and feet of the arm beds have given rise to machines which differ greatly in appearance, although the actual stitch forming elements contained in these machines remain basically the same. These mechanisms may be grouped under one or other of the two main headings: rotary hook or oscillating shuttle. The principal features and sewing equipments of a modern flat bed Lockstitch machine of the rotary hook type are illustrated below in the figure. The primary components concerned with the formation of the stitch are the needle, the feed dogs, throat plate, pressure foot, the rotary sewing hook, and bobbin and the bobbin case. Each of these components is a precision product, and for its proper functioning must be in perfect condition with their positions accurately set, and in the case of moving parts, perfectly timed in relation to the movement of the other components. Stitch forming action of the rotary hook Lockstitch machine. Rotary hook machine forms the plain stitch or simple two-thread lock stitch by carrying the needle thread loop around a bobbin containing the under thread. Commencing with the needle at the lowest point of its stroke, the needle starts to raise the needle thread, which, being flexible, bulges out away from the needle to form a loop. The loop formed in the needle thread is then entered by the point of the sewing hook. As the needle continues to rise and the hook progresses in its rotation, the needle thread take-up arm provides sufficient slack thread to be drawn down through the fabric to increase the size of the loop. On its first rotation, the sewing hook carries the needle thread loops around the bobbin case and bobbin. The inside of the loop sliding over the face of the bobbin case, whilst the outside passes around the back to enclose the bobbin thread. As the needle thread take-up starts to rise, a loop is drawn up through the cast off opening of the sewing hook before the revolution is complete. During the second revolution of the sewing hook, the thread take-up completes its upward stroke, drawing the slack thread through the material and settling the stitch. Meanwhile, the feed dog has moved forward, carrying the material with it and drawing the required length of under thread from the bobbin. The pressure foot guides against the slippage by holding the fabric firmly against the teeth of the feed dog, whilst the feed dog is carrying the fabric across the smooth face of the throat plate or needle plate. Now that it is clear to us that how a lock stitch is formed, there are many factors that can prevent the correct formation of the stitch. Namely, they can be anything which inhibits the formation of the needle thread loop, or anything which prevents a correctly formed loop from being entered by the point of the sewing hook, or anything which interferes with the free running of either the needle thread or the bobbin thread. Apart from this, there are other factors that influence the formation of a satisfactory seam, which as the size and type of the needle and sewing thread, the relative tensions in the thread lines, and the type of fabric and the manner in which it is fed across the throat plate of the machine. Characteristics of Lockstitch machine. Uses the least amount of thread. The Lockstitch machine consumes and use very least amount of the thread. It produces the flattest stitch. It allows stitches to bend into the fabric surface. It is reversible and thereby it is used extensively for top stitching. It is tightest and most secure stitch. This is only stitch formation that can be back stitched. It has the least amount of elongation potential and thereby it is inappropriate to attach elastic or sew knit fabrics or bias seams that are expected to stretch. Machine parts and functions of Lockstitch machines. Some of the machine parts play an important role in stitch formation. The following is a list of such parts along with their functions. Machine part, that is presser foot. Function, it presses the material being sewn against the feed dog and the throat plate. It facilitates stitch formation and feeding. Machine parts has throat plate. Function, it provides opening for the needle and the feed dog. It provides a smooth surface for feeding of the fabric. Machine parts as a feed dog. Functions, it moves the material towards and forward by one stitch length after each stitch has been drawn. Take up lever, it draws the needle thread from the bobbin. It releases the required length of thread for making stitch. Tightens the stitch. Thread guide, it keeps the thread in its proper course. Check springs, it even outs the tension fluctuations. Tension discs, it ensures correct tension for looping. It also ensures that thread does not get entangled on its passage to form the stitch. Needle bar, it holds the needle in vertical position and moves it up and down for stitch formation. Rotary hook, it catches the needle thread loop and lays it around the under thread spool. Stitch regulator, it used to regulate the stitch length. And last is back tack lever, it reverses the movement of feed dog and enables stitch formation in the reverse direction. The three-thread overlock. This stitch is also known as over edge oblique edge seaming or cover seaming. It is used extensively in the making up of knitted goods and for serging woven fabrics in the garment industry. In its basic form, the stitch comprises 3 threads, a needle plate and 2 looper threads. It is the needle thread which actually stitches the plies of the fabrics together, whilst the looper threads interlock with the needle thread above and below the fabric and with each other on the trimmed edge of the fabric, for which purpose trimming cutters are provided. The interlocking of the looper threads binds the trimmed edges of the fabric, preventing fraying and unraveling. The stitch has the advantage of very high extensibility. This property makes it eminently suitable for use in readily extensive fabrics, knitwear and making up of tights. Sewing machine feeding system. The material handling components of a machine are often referred to as the feeding system. For a precise line of stitches to be formed, fabric must be moved through the stitch forming area of the machine with accuracy and precision. The feeding system controls fabric movement. It usually consists of 3 parts, that is the pressure foot, the throat plate and the feed mechanism. Each of the parts has many variations in shapes, sizes and functions. They are specific to the machine type, number of needles used, types of attachments used and types of operations. They are parts of a system and must be compatible. If one is changed, the other part must be changed to make the system work effectively. Pressure foot. I think AC we can on to pressure foot. The pressure foot is the upper part of the feeding combination that holds the fabric in place for the feeding action and stitch formation. The pressure foot, which is attached to the pressure bar, controls the amount of pressure placed on the fabric as it is fed through the machine. The amount of pressure can be adjusted for the sewing speed and fabric type and weight. Higher speeds may require more pressure to control the movement of fabric. Flagging occurs when the fabric rises and falls with the needle action. This interferes with stitch formation. Flagging cannot be used, but it should be prevented with more pressure and a smaller needle hole in the pressure foot and throat plate. The basic pressure foot may be constructed as a single unit or hinged to facilitate movement over bulky seams. The most common type is the flat pressure foot, which consists of a shank that attaches to the pressure bar and the shoe that rests on the surface of the fabric. Figure shows the basic parts of pressure foot, that is shank, heel and sole. Parts of a pressure foot. Variations in the basic pressure foot occur in the shoe parts, which include the sole, heel and toe. The sole is the surface that is in direct contact with the fabric, which may be smooth, toothed, channeled and so on. The toe is the forward portion of the shoe that is responsible for holding, guiding and positioning of unsewn fabric. The heel is the back portion of the shoe that is primarily responsible for holding fabric and retaining its established position for the feeding and stitching action to take place. Each of these areas of a pressure foot has many variations that are adapted for specific operations. There are well over 100 different types of pressure feet, and each is specific in function. Some of the possible modifications of pressure feet are short toes for sewing curves, long toes for long straight seams, offset soles for stitching along raised edges of fabric, patch pockets and collar edges, channeled soles for fitting over bulky lapped seams, solid narrow feet for sewing close to raised edges or zipper chain, and so on. Some of the more specialized feet contain other operational parts. Pressure feet are uniquely designed for different sewing operation and can be changed readily, but they must be coordinated with other feeding and sewing parts. Throat plates. Throat plates are removable metal plates attached to an adapted plate or throat plate support directly under the needle. Throat plates support the fabric as the needle penetrates to form the stitch. Throat plates have openings for needles and lower feed devices. The appropriate size and shape of the throat plate varies with the machine type and its specific function in the stitch forming process. The number and size of openings in a throat plate depend on the number, size and action of needles and the number and location of feeds. Throat plates are interchangeable and must be compatible with other stitch forming and fabric carrying parts in order for stitches to be formed properly. Sewing machine needles. Functions of sewing machine needle. The functions of a sewing machine needle are to produce a hole in the material for the thread to pass through and to do so without causing any damage to the material. The tip carries the needle thread through the material and forms a loop which can be picked up by the hook on the bobbin case in a Lockstitch machine or by the looper or other mechanism in other machines. To pass the needle thread through the loop formed by the looper mechanism on the machine other than Lockstitch. Types of the needle. For use in a particular machine, needle must conform to the machine manufacturer's specification as regards shank diameter, length for butt to eye, and total length. Some types of needles used for different machines are given below in the table. For single needle Lockstitch machine, the needle used is DB cross 1. For double needle Lockstitch machine, needle used is DP cross 5. Single needle chain stitch machine, that is class 401, the needle use is DB cross 5. Overlock machine, the needle used is DC cross 1 or DC cross 27. For feed up the arm machine, the needle used is UB 128 gas. For Bartek machine, the needle used is DP cross 5. For button stitch machine, the needle used is TQ cross 1 or TQ cross 7. And for flat lock or buttonhole machine, the needle use is TB cross 1. Thread consumption. It is important to know the amount of thread consumed in a sewn product, so someone can estimate the number of cones needed, calculate the cost of the thread needed to manufacture the finished products. Thread consumption can be determined in several ways. To calculate the amount of the thread in a seam, it can be measured the actual amount of thread consumed in a specific length of seam. It can also calculate the thread consumption by using mathematical stitch formulas based on the thickness of the seam and the number of stitches per inch, and also it can calculate the thread consumption using thread consumption estimate. Measuring actual thread consumed. A specified length of the thread or seam, for example 3 inches, is measured on the seam. Then the thread is removed by carefully unraveling the stitch. Someone can then calculate the amount of thread consumed in one stitch and multiply this factor times the total length of the seam measured in inches. Obviously, someone must do this for each seam to determine the total amount of the thread consumed in the finished product. For example, suppose length of the seam is 42 inches. Stitch and seam construction is of superimpose 401 seam. Specified length of the thread removed from the seam will be equal to 3 inches. Needle thread removed is 9 inches and looper thread removed is 8 inches. Now calculation. Needle thread factor, that is 9, and 3 inches of needle thread per inch of the seam, and looper thread factor for 8 inches will be 2.67 inches of looper thread per inch of the seam. So total needle thread consumed is equal to factor 3 into, if we will convert into 1.717 yardays or 42 inches, so it is 3.51 yardays. Total looper thread consumed is factor 2.67 into 1.17 yards, that is 3.12 yards. Total thread is 3.51 plus 3.12, that is 6.63 yards per seam. Generally, a 15 to 20% waste factor is added due to chaining of thread breaks, repaired, etc. If the waste factor of 15% is selected, then 6.63 yards per seam will be multiplied by 1.15 factor. It will be 7.62 yards per seam, including 15% of the waste factor. Thread consumption formula. Union Special Machine Company published a thread consumption booklet that consists of a number of thread consumption formula for various stitch types based on the stitch length and thickness of the seam. These mathematically derived consumption factors can be multiplied times the length of the seam to estimate the combined amount of top and bottom thread. On some overage and cover types, it is necessary to also know the seam width or needle spacing to properly calculate the amount of thread consumed. In Union Special 401 chain stitch chart, the seam thickness is, and second thing is given that 8 SPI. So if the seam thickness is 0.055, in 8 SPI it will be 4.88. If the seam thickness is 0.60, it will be 4.96, and so on. For example, stitch and seam is of 401 superimpose seam. Stitches per inch is 8, SPI is 8, and thickness of the seam is 0.75 measured with a micrometer. The length of the seam is 42 inches or 1.17 yards. Then calculating the same thing, calculation based on the mathematical equation, that is C is equal to 4 plus 2 TS. Here again the C is consumption will be equal to 4 plus 2 under bracket 0.075 multiply by 8, so it will be 5.20, where T is the thickness of the seam and S is the stitches per inch. So in this case it will be 1.17 yards multiplied by 5.20, so it is 6.08 yards per seam. 6.08 yards per seam will be multiplying with 1.15 will be 7 yards per seam, including a 15% waste factor. Estimating thread consumption. As you are aware that Union Special chart, the more stitches per inches, the thickness of the seam impacts the amount of thread consumed. However, most heavy fabrics are sewn with fewer stitches per inch, and the most likely fabrics are sewn with more stitches per inch. Therefore, we have come up with the following estimates based on the typical seam thickness and stitch length. Stitch and seam is 401 superimposed seam. Length of the seam is 42 inches again, or 1.17 yards. Fabric weight is lightweight. Estimated thread consumption will be 1.17 yards. Multiply by 5, it will give the 5.85 yards per seam. And 5.85 yards per seam multiplied by 1.15 will give 6.73 yards per seam, including a 15% wastage factor. Estimated needle thread will be 6.73 multiplied by 40%, 2.69 yards, and estimated looper thread will be 6.73 multiplied by 60%, it will be 4.04 yards. So here next is the chart where stitch type, estimated total consumption ratio, needle thread and bottom thread the calculation is mentioned. In this table, start with the lock stitch, that is the 301 stitch class. The stitch number in fact is 301 and stitch class is 300 class. The estimated total consumption ratio will be between 3 to 4. It depends on the thickness of the fabric, it depends on the SPI of the stitches, where needle thread will be 50% and bobbin thread will be, or bottom thread will be 50%, because loop formation happens in the center and it is both sides looks the same. 401 chain stitch, the estimated total consumption ratio will be between 5 to 7. For lightweight fabric, it's a 40%. For medium and bottom thread will be 60%. Needle thread 40%, bottom thread 60%. For medium weight fabric, bottom thread and needle thread will remain the same, that is a 50-50%, and for heavy weight fabric, the needle thread will be 60% and bottom thread will be 40%. For 503 over edge, that is a 2 thread stitch, the factor will be 7 to 10 and the needle thread will be of 60% and bobbin thread will be 40%. Another over edge, that is 504 stitch number, comes under 3-thread overlock, and here the factor vary from 12 to 16, where 25% will be the needle thread and 75% will be the bobbin or bottom thread. 515, that is a mock safety stitch, and that is 4-thread overlock. Here the factor will be 12 to 17 and 55% will be the needle thread and 45% will be the bobbin thread. Next is 5-thread overlock, that is the stitch number is 516, that is safety stitch. The factor will be 17 to 23 and here needle thread will be 37% and bobbin thread will be 63%. This chart can be used lower estimated thread consumption numbers for lightweight fabrics or long stitch length. On the chain stitch construction, the amount of looper thread does not change unless the stitches per inch changes. On the other hand, the needle thread will change based on the thickness of the seam. Therefore, the percentage of needle thread goes up when the fabric gets heavier. Lightweight is generally like shirts and blouses. Medium weight is generally like slacks and chinos, and heavy weights are generally like denim applications.